Hello, everybody. Welcome to a new episode of the Dissenter. And today I have the great honor of being here with Dr. Noam Chomsky. He holds a joint appointment as Institute Professor Emeritus at MIT and Laureate Professor at the University of Arizona. And he is the author of over 100 books on topics such as linguistics, war, politics, mass media, and others. So, Dr. Chomsky, thank you for taking the time to come on the show. It's a real honor to everyone.
Thank you very much.
Okay, great. So I would like to go through some of the major highlights of your intellectual life that is very long by now. And the first question I would like to ask you is, since you were one of the major figures that was behind what we call the cognitive revolution back in the 50s and 60s. What would you say was the importance of that revolution in terms of studying human behavior?
Well, the last two words are crucial. The standard approach to the study of human beings at the time was called behavioral science or behaviorism. Inquiry was pretty much limited to actual behavior, organization of behavior, description of behavior, eliciting, controlling behavior, and so on. But that's not the way you study any organism if you want to understand it. So what you want to do is try to understand what the internal mechanisms are that are causing the behavior. And that was considered improper at the time. You had to keep to the analysis of behavior. So the cognitive revolution, so-called, was pretty much what the word suggests. It was trying to study the nature of the cognitive processes that are being carried out internally, what we call mental processes in the brain, which we try to describe and discover and see how they eventuate in behavior. This was not entirely new. There was a kind of a cognitive revolution in the 17th century, which began to study such questions early at the beginning of the scientific revolution. Among the topics that was investigated among those topics were vision, language, other topics that became central in the revived cognitive revolution of the 1950s. So in the case of vision, for example, if you go back to 16th century assumptions, it was believed that if you perceive a triangle, the form of the triangle somehow passes through space and implants itself in your mind. And Galileo and other initiators of the scientific revolution regarded that correctly as mysticism and wanted to discover what the actual mechanisms were. So, for example, Descartes argued that the way you see a triangle, he argued, is kind of the way a blind man with a stick would see it. A blind man would touch various points on the triangle, a series of stimuli, and the mind would create the image of a triangle because the mind works on principles like Euclidean geometry. That turns out to be rather accurate. It's not a stick reaching from the object to you, but it's eye motions called saccadic eye motions, which just, when you look at something, you don't see it. What you see is a series of stimuli around, and your mind constructs the image. When I construct the image of you or triangle or anything else. In the case of language, there were quite interesting developments. Galileo and his contemporaries were amazed and shocked at what they regarded correctly as a most remarkable phenomenon, that with a few dozen symbols, we can somehow construct in our minds an infinite number of thoughts, and we can even convey those thoughts to others who have no access to the workings of our mind. Galileo thought that the alphabet was the most stupendous of human inventions because it could carry out this miracle. Of course, because it was based on an internal alphabet collection of symbols that was manipulating it. And quite interesting investigations began of the nature of these processes. Well, this was all forgotten during the structuralist and behaviorist period. The whole tradition was forgotten. And it was revived in the mid-1950s without any awareness of the history that had been forgotten. It was only discovered later. But it was revived with new tools. So the development of the theory of computation, one of the great mathematical achievements of the 20th century, Alan Turing, Gödel, other great mathematicians, that made it very clear how a finite object like your brain or your laptop would have the capacity to generate, to construct an infinite unbounded number of structured expressions, each of which can constitute a certain thought and can be externalized, usually in sound or some other medium. That made it possible to begin to study the traditional problems of language that had been left hanging because they didn't have these concepts, to study them in a direct and serious way, to try to construct precise theories that would account for the knowledge that you and I have and largely share, which makes it possible for us to communicate. And the same was true in the study of vision. It was abetted in the case of the study of vision by a new technology that made it possible to discover what neurons are actually doing in the visual sectors of the brain. If they didn't do it with humans, that would be unethical considered, but it was considered ethical to work on cats and monkeys by implanting electrodes in the part of their brain that picks up visual symbols and to discover exactly what they're doing. And some pretty remarkable discoveries were made. And in the case of language, the problem is much harder. One reason is the systems are much more complex. The other reason is there's no comparative evidence. Since language is a unique human property, no analogs in other species, which is a striking fact in itself. You can't study monkeys, apes, cats, any other organism to do the experiments that would not be permitted on humans. Mm-hmm. So you have to use much more indirect means. Nevertheless, there are advances in technology which make it possible to learn something about what the brain is doing when you and I are communicating. But most of the work is just intensive study of a wide variety of typologically varied languages to see if you can understand the mechanisms that are carrying out this miraculous achievement that so amazed Galileo and others. And quite a lot has been learned. So, for example, if you go back to the 1950s, it was standardly assumed in the structuralist behaviorist tradition that languages could vary in almost arbitrary ways, and that each language had to be studied on its own without preconceptions. That's now known to be quite wrong. Turns out that as we proceed, languages that look very different on the surface seem to have pretty much the same internal structure, with meeting the same principles, the way they compute thoughts and transmit them to the outside. And a fair amount has been learned about these principles. Well, the cognitive revolution deals with, in principle, with all cognitive capacities, but the most far-reaching results have been in language, vision, a few other areas.
Mm-hmm. Okay, let me now move on to ask you about what has been known as the Chomsky-Piaget debate back in 1975. This was very interesting because Piaget brought to the table an approach to children's development, particularly regarding language and other aspects of cognition, that was different from the behaviorists, but also regarded an interaction between the agent and its environment. And on the other hand, back then you defended a more innatist or nativist approach to those kinds of problems. So could you tell us briefly maybe what were some of the biggest issues that were debated back then?
Well, the biggest issues were exactly what you just said, is development of language capacity and other cognitive capacities a matter of following a fixed plan that's part of our genetic endowment, modified, of course, by the environment. So your genes don't determine whether you speak English or Spanish. But is there a kind of a basically fixed plan that directs the child reflexively? The child doesn't think about it any more than you think about growing arms, but it sort of sketches out the basic plan of development with experience, modifying it around the edges? Or is there some process of maturation or moving from stage to stage, which that doesn't involve any innate genetically determined components? And that was the core argument, the debate. Incidentally, neither Piaget or I regarded it as a debate. The debate idea was created by the publishers. It was supposed to be a conference where he and I opened it with our own presentations, and others came in and gave their presentations. But I guess the publishers felt that they could sell the book better if they turned it into a debate, but neither of us approved of that move. But it was a discussion among many cognitive scientists, some from Piaget's Institute, Barbara Inhelder and others, some from here. My friend Jerry Fodor was an active participant, and others. And there was a lot of interaction about the nature of these problems.
Mm-hmm. And wasn't it another issue that was brought to the table, the one that had to do with modularity of mind? And you and Fodor, if I'm not mistaken, defended a position where you believed that the mind was composed of several different modules, each of which had to deal with different cognitively distinct problems, correct?
That's correct.
Mm-hmm. And would you say that those different modules were the result of natural selection and are mostly genetically determined, or at least genetically based, or not?
First of all, we have to distinguish genetically determined from a product of natural selection.
Okay.
Remember, Piaget in particular was very skeptical about natural selection altogether. Mm-hmm. In fact, so much so that a number of the distinguished biologists present, Jacques Monod, François Jacob, the laureates in biology, were pretty much shocked by some of his positions. Actually, some of what he proposed then does not sound quite as exotic today as it did at the time, because of discoveries in what have been called, it's been called epigenetics, the way experience has some peripheral limited effects in complex ways on changing the nature of the genetic endowment. But his general anti-Darwinian position is not suggested. And my case, and also Fodor and Massimo Piatelli, who organized the meeting, who was a biologist. In fact, Fodor and Piatelli have just written a book recently called Why Darwin Was Wrong, in which they review many discoveries in recent years, which have shown that many natural processes take place that are critical for evolution over and above natural selection. They even raise some questions about the nature of natural selection, but I think we can concede that that's a critical element of evolution. Darwin was largely right about that, but there are many other ways in which the genetic, the genome, the arrangement of genes changes through genetic drift, transposition of genes from one place to another, even from one organism to another. Lots of processes take place that yield the genetic endowment of the particular organism. Its genotype. So yes, I think it's, my view, reasonably clear that there is a specific genetic endowment for language that humans have, no other organism has. That's why, as I mentioned before, we can't do the kinds of comparative studies about language that you can do with vision and other pretty much shared capacities. There's no known explanation for that other than genetic endowment. Of course, to find the basis in the genome for particular capacities is very difficult, even for simple traits like height, let's say, where nobody doubts it's genetically determined, to try to find the hundreds of genes involved in determining height is what biologists sometimes call fiendishly difficult problem. So it's not going to be simple to find the genetic endowment for language. That's a huge problem. But the fact that it's there, I think, is pretty well established. In fact, that's why an infant, a 2-year-old infant, has an amazing knowledge of language, as you can discover by experiment, even though it's had very little experience. Why, if you look at the language development of infants, it goes through a very fixed program of development. In fact, a newborn infant already has some information about the language of its mother, can identify the language of its mother as distinct from another language, both spoken by a woman whose voice they've never heard, a bilingual woman. And by now, lots understood about that. And then there's a regular series of progressions that the infant goes through. Of course, it's modified by experience, but it seems to be just similar to other genetic programs. There have been efforts, extensive efforts, to try to elicit something like language behavior from other organisms, usually apes. It's been a total failure. They simply don't have the cognitive capacities that allow them to use the data that an infant uses just reflexively. That's also has to be the basis for the fact that languages generally seem to be cast to the same mold in some deep sense, even if they look on the surface to be very varied. I should say that this doctrine about the almost endless variation of languages was also held about organisms in the 1950s. So a standard view among biologists was that organisms are so varied that you just have to study each one basically on its own. That's now known to be completely wrong. Discoveries of recent years have shown that there are very few types of organisms. They have deep properties that they all share. This it's even been suggested, taken seriously, that there's a universal genome, a single fixed genome, which slight modifications gives you different organisms. It's pictures somewhat like what seems to have been discovered about language over the years. A lot of this is contentious. I don't want to suggest that there's an overwhelming consensus about that, but that's the way the evidence looks to me increasingly. I don't see any, I really see no serious alternative to this view.
Okay. But since you agree that we have at least certain aspects of our cognition that are genetically determined, and you also agree for the most part with the modularity of mind position, I've heard you criticizing several times the discipline of evolutionary psychology, since those are basically two of its theoretical foundations. Why is that? What do you think are its main flaws?
Well, I don't criticize the discipline of evolutionary psychology. I think it's a fine discipline. In fact, my own work falls within it.
Okay.
But it's the practice of evolutionary psychology that I think has to be viewed very carefully. A good deal of the practice makes enormous imaginative leaps on the basis of very scanty evidence. Jerry Fodor, for example, who you mentioned, who does believe in modularity of mind, has written scathingly about the practice of evolutionary psychology. There is work that's significant and serious, the work on kin selection, on evolution of altruism, Robert Rivers' work, others, but a good deal of it is pretty fanciful. It's constructing possible stories on the basis, which have a lot of implications for human life, on the basis of very thin and dubious evidence. So I think we have to be pretty cautious about it. And just as you'd be cautious about any field, but in particular in this case, one has to be very cautious because of the apparent implications for human life and human society. And that's a serious matter. You can't just speculate wildly about that.
So your opinion is mostly that some of the conclusions that are drawn from the activity done in evolutionary psychology perhaps are not well supported by the evidence.
I think that's unfortunately true. And as I say, there is a fair amount of critical work on this. Fodor's written about it. Major biologists, Richard Lewontin, Stephen Gould, have written critical assessments of it. And I think a lot of what they say is well-founded. Lewontin, in particular, a well-known evolutionary biologist, has strongly argued that we should be careful about what he calls just so stories, like Kipling, just making up nice stories about animals or humans based on some often just metaphoric relationship to what might have happened in evolution, where we really have no knowledge of how it happened. It's very hard. Evolution's a hard field. You can't just wave your hand and say this happened because of natural selection. It doesn't mean anything. To find the actual mechanisms is no small, and the actual processes that took place is no small problem. In the case of, in fact, it's kind of interesting to take a look at what is studied and what isn't studied. It tells you a lot. So take honeybees. They have a very elaborate communicative system, the famous waggle dance. So for some species of bees, the bees will fly away from the hive, wander around. Some of them will hit a flower. They'll go directly back to the hive, which is actually called a beeline because they go straight back to the hive, which is not a simple task. Humans can't do it. When they come back to the hive, they perform a certain kind of dance. They wave their wings around in a certain way. That informs the other bees in the hive of the direction, the height, and the distance, and the quality of the flowers. So it's a pretty tricky communication system. It's been studied quite well. The neurophysiology of it is not at all understood. I mean, it's obviously genetically determined, but nobody can find the genes. What about the evolution of this system? Well, just think about it. There's hundreds of species. They differ a little bit. Some don't have this dance at all. Some have variants of it. Bees have a tiny brain. It's about the size of a grass seed. You can do any experiment you want. Stick electrodes in anything you think of. No ethical conditions. There's almost no study of it because it's very hard. Come to humans, incomparably more difficult. Huge brain, can't do experiments, no comparative, one species, no comparative studies, the huge literature on evolution of language. That already tells you that we're moving into an area of deep speculation. I mean, it's not that you can't say anything about evolution of language. I've written a book about it too. There's a few things that you can say, but it's an immensely difficult topic as compared with, say, evolution of bee communication, which is understood by biologists to be a very hard problem that you can barely study. If you try to Google it on the internet, you'll find some scattered studies, but not much because it's hard. That tells you something about studying evolution.
Mm-hmm. So let me ask you now about a debate that you had back in 1971 with Michel Foucault. And I would like to focus mostly on the first part of it, that was about human nature from an epistemological perspective, that I guess you had very dissimilar views there. I think that Foucault focused mostly on how the kinds of social environments and cultural environments that we inhabit basically are responsible for constructing our cognition. But again, I think that you brought to the table a more innatist perspective. Is that correct?
That's correct, although frankly, I don't think there's an issue. I mean, human nature, humans are organisms, just like bees or apes or dogs. Every organism has a genetically determined nature. I have dogs, okay? The dogs can do certain things which I can't do, but they can't do certain things that I can do. That's not because of their experience. That's just because that's the way they're designed and the way I'm designed, okay? That's their nature. Now, there is a kind of a, in my view, rather mystical belief that, yes, we have a nature, but it's only responsible for our physical characteristics. When we move to our cultural, mental, cognitive characteristics, it's just somehow comes from somewhere else. I mean, there's no basis in science, history, experience, anywhere to countenance that view. When you hear people say, even serious people, humans have no nature, only a history, that can't be correct. If you didn't have a fundamental cognitive nature, you couldn't understand anything. You would just be some hopeless amoeboid-like creature wandering around aimlessly. Even to have experience requires a fundamental nature. So when I look at this screen, I see a person. Why do I see a person? Why not just a lot of colors and shapes around. And every young infant also sees a person. That's because we have an internal nature that provides our experience. When you see the moon rising, why do you see the moon rising? Why not just an array of colors and shapes that has no form? I don't know if the dog sees a moon rising, probably not. Even the simplest datum, simplest part of experience is already constructed by the mind. That was understood in the 17th century. We have much more evidence for it today. So at every aspect of our cognition, our mental life, our social life, it's must be based crucially on elements of our nature. Now that doesn't mean that experience doesn't have an effect. Of course, it has a huge effect. So for example, take an issue that's very much alive today, a crucial question about the nature of our society. Should people be slaves obeying the order of a master? Okay, is that legitimate? Well, so should we accept a totalitarian state which controls and orders the actions and even the thinking of its citizens? But we would all say no to that. But while we say no to it, we accept it. That's what a business is. Take any business enterprise. A worker goes in the morning, and until that worker leaves in the evening, they're a slave. They're controlled to a level that goes way beyond what anyone would imagine in a totalitarian state. So, for example, Stalin, let's say, that didn't control when people were allowed to go to the bathroom for 15 minutes, for 5 minutes, didn't control when people were allowed to talk to each other, what clothes they had to wear. All of this happens in every business all the time. So is the labor contract legitimate? Well, if you go back in history, you have different views on this. So in the early Industrial Revolution, American workers were very militant, very opposed. Their view was if you work for a wage instead of under your own control, you're just a slave. Actually, leading figures of the Enlightenment believed this. So Wilhelm von Humboldt was one of the great figures of the Enlightenment, also a great linguist and humanist, founder of the Modern Research University, but one of the founders of classical liberalism. His view, which was not unusual, was that, as he put it, if an artisan creates a beautiful object on command, we will admire what he does, but we will despise what he is, namely an automaton controlled by someone else, obeying orders. That's not a free human being. That view was held. That was actually a slogan of the Republican Party in the mid-19th century. Abraham Lincoln believed it. There's a big struggle today about whether, in fact, even the most elementary structures of our social organization have any legitimacy, or whether they should be dismantled just the way slavery was. Okay, this is a critical question. Has to do with it's often argued that it's just part of our nature to want to be subordinated to hierarchical structures that control us. Very commonly argued. That's the way our nature is. We have to have this. Same arguments were made about slavery. Blacks are just genetically, they didn't say genetically in those days, they're designed by their nature, maybe by God, to pick cotton in their backs, to be, that's the way they're happy. It'd be unfair to do anything else. Similar arguments are made today about the basic structures of our economy. So there are real issues, live issues about what our nature is, what is a proper way for our nature, what kind of social organization would be appropriate for our intrinsic nature to flourish? Those are serious questions. Science doesn't tell us anything about them. Mm-hmm. Evolutionary psychology doesn't. Experience tells us some things. History tells us things. We can think about it in various ways. But it's just a kind of a truism that everything about us is some kind of combination of our intrinsic nature and the environment, social, personal, other aspects of the environment in which we develop. And those parts are controllable. We can change them. So a person who's interested in constructing a better world, working for what's called the common good, will be very concerned with these issues.
Mm-hmm. So, yeah. So let me just ask you one last question before we go. Regarding what you were just saying in terms of trying to find out what kind of social organization would allow for us to better express our human nature and to flourish, I think that another issue that you also debated with Foucault had to do with creativity. So is that one of the things that we have to keep in mind? To allow for people to be creative when trying to devise a better system of social and political organization?
Well, I think so. I'll go back to Wilhelm von Humboldt again. He regarded the essence of human nature as being the desire to inquire and create. You see it in young children. They're very inquisitive. They want to understand everything. They want to make new things and so on. It's sort of beaten out of them by the educational system. But it ought to be, I think it should be a proper educational system, should be nourishing it and allowing these qualities to flourish. Now, that's actually what happens in decent progressive education systems. But much of the system is devastating. So take the reigning system now in the United States, which is called teach to test. You have to teach in the schools in third grade. You have to teach them what they can use to pass a test that's given at the end of the year. That's a way to ensure that people understand nothing, go nowhere. We've all had the experience of taking a course in school, which was taught very badly. We had no interest. Work hard enough to pass the test, and 2 weeks later, you forgot what the course was about. Well, everybody's had that experience. We've also had, if we're lucky, had the experience of being in environments where your instinctive a tendency to seek to inquire and create is nurtured. Opportunities are offered, encouraged. Now we know the consequences are quite different. Well, I think that holds for society in general. It's one reason why I think it's dramatically opposed to human nature to have social institutions in which people spend much of their waking lives basically as slaves.
Mm-hmm. Okay, so Dr. Chomsky, I guess that we've already arrived at our time limit, unfortunately. And again, it was a real pleasure to have you on the show, and thank you a lot for taking the time to come on. It was a real pleasure to talk to you and to meet you. So,
thank you very much. Enjoyed the opportunity.
Hello everybody, thank you for watching this interview until the end. As you might have noticed, I've been putting out regular interviews with academics and intellectuals from a variety of fields. So to keep the channel sustainable, I would like to ask you to please visit my Patreon page and to consider making a pledge there. Any amount, even just $1, would already be a great help. Otherwise, and if you like what I'm doing, please share it, leave a like, and hit the subscription button. I would also like to give a huge thank you to my patrons and PayPal supporters: Karen Litske, Anne Blanchett, Perel Galarson, Lau Guerrero, Chantel Gilinas, Francis Ford, Hans Fredrik Sunda, Brian Rivera, Lucas Stafiniak, Sérgio Condriano, Janne Henninen, Ricardo Vladimiro, Craig Healy, John Connors, Adam Castle, Vega Guidi, Olaf Alex, Jonathan Wiesel, David Dias, Anian Kata, Jacob Klinkby, Dr. Jerry Mueller, Herbert Gintis, Rutger Voss, and Bo Weingart. My three producers, Isar Weber, Rosie, and Jim Frank, and my executive producer, Mikhail Ruzieski. Thank you for all.